Alright, so we have a problem. The camera is located 50 feet from a straight road, which a car is traveling 100 feet per second. So he's speeding, by the way. 88 feet per second is 60 miles an hour. This guy's going to get nailed and sent a ticket. Snap, 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 snap. Here's your $180 ticket. The camera turns so that it's pointed at the car at all times in rads per second. How fast is the camera turning so as a car passes closest to the camera? Per second means this is related rate. This is not optimization. You don't know what optimization is yet, don't worry. We have this condition. We got, and it says as the car passes close. So it's coming this way towards the camera. X is the distance I have horizontally. It is 50 feet, which never changes. So I don't need to put a variable here. The camera is not moving from the road. So this distance can just be called 50. I don't have to have a variable for this. And I'm looking for theta, guys, and how fast theta here is changing. Now my question to you guys, is it going to be positive or negative? Should be negative. As a car comes close to the camera, we should be swinging this way. The angle should be decreasing. The rate of change of the angle should be negative. We'll go through why. Did you have negative? Now, everybody, here's the other thing. This should be a negative 100 feet per second, right? You probably don't have that rate. Because the car is closing in on that, this is negative 100 feet per second. Check your work there. And we're looking for d theta dt at when the car passes right at this point. That is at theta equals 0 rads or 0 degrees. What's our equation? Our equation this time, I think, is pretty easy. It's tangent of theta equals x over 50 feet. And the derivative of this is pretty easy. We're going to take the derivative, and since it's a related rate, we do it with respect to time. Derivative of tangent theta is secant squared theta, d theta dt. The derivative of 1/50th x is 1/50th of a foot dx dt. All right. Now we can do a little work here, and then I'll go. And I don't usually do this, but I did it this time. I solved for d theta dt in terms of variable. I divided by secant squared. And everybody, if it's at 0 degrees, close 1 over, I'm figuring out what secant squared is here. All right, 1 over cosine squared 0 is 1. When I do the math here coming up. So now, and this is probably where you have your sign mistake if you just got 2. All right. I plug in 1/50th of a foot. I plug in negative 100 feet per second because the car is closing in on the camera. The feet cancel. This is 1. And I got negative 100 divided by 50, which is negative 2 per second. Now, is that right? The answer is yeah, because remember, radians are unitless. So I get negative 2 rads per second. It is the rate of change. All right? And this is a related rate problem, and these are the steps it should be shown. All right?